Going to continue on with our decimal unit, and today we're going to start with lesson 10. I can use area models and the number line to compare decimals and record comparisons using less than, greater than, and equal to. In our first example, we see 0 and 19 hundredths is greater than, less than, or equal to 3/10. And how we're going to look at this, guys, is we're going to use these area models to help us compare the two decimals. Now, if you look, let's try to take apart this 19 hundredths by using a number bond. Okay, so down here, I'm going to split this up. I've got 1/10, and the 9 represents 9 hundredths. So what I'm going to do is I'm going to color in 1/10 right here. But now if you look, we have 9 hundredths. So within each one of these boxes, we would cut this up into another tenths, because 10 times 10 is 100, and within each one of these boxes there's another tenths. So that would be hundredths. So if I split this up into tenths, this would be hundredths. So let's make this halfway here. So we've got 1, 2. Okay, that represents 5 there. Not very kind of sloppy. 1, 2. Okay, so there's our 10. So we split that up into tenths. So in that tenth, we made another tenth, which would give us 100. So now we need to color in 9 hundredths. So here we go. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that represents 19 hundredths. So on the other side, we have 0.3, which really means 3/10. And we are going to just shade in, well, if we actually let's make a number bond of 0 and 3/10. So we've definitely got 3/10 and nothing else. We could say we have no hundredths because we are comparing the two. So we have no hundredths, but we have 3/10. So that makes it kind of fair that we can complete that. So if we have 3/10, let me get my marker, excuse me. This becomes 3, 1, 2, 3, 3/10. Now if you're comparing them, there's no argument here. We know just by looking at the two area models, 3/10 is the winner. So 0 and 19 hundredths is less than 0 and 3/10. All right, next example. Get 0.6 is greater than, less than, or equal to 0.06. All right, so what we want to do is we want to use those area models to help compare. But before we do that, let's make our number bonds. 0.6, okay, and I have 6/10. I do not have any hundredths since we are comparing going up to the hundredths. I'm going to put that in there to help me. And I'm going to make another one, 0.06. We do not have any tenths. However, we have 6 hundredths. All right, so what we're going to do is we are going to go into our area model, first one, 0.6, and we are going to shade in 6/10. 1, 2, 3, 4, 5, 6. This represents 6/10. Now on the other side, we do not have any tenths. So we will not be shading one of these here, this hole here, because there's no tenths. We jump right into the hundredths. So just like we did in the last problem, we need within each one of these tenths, there could be another tenths, which would give us hundredths. So let's split this one up into tenths. All right, so now I just took that 1/10 and I split it up into another tenth, which gives us hundredths. So let's color this in to represent 6/100ths. So we've got 1, 2, 3, 4, 5, 6. So that represents our 6/100ths. Just by looking at the two area models, we can see that this one is greater, is shaded in much more than that one. So the winner is, who's the greatest, is 6/10. So let's put the greater sign facing the 6/10 because that's the bigger side. The smaller side is facing 6/100ths because it's the smaller decimal. All right, now they want us to compare the decimals, but this time using a number line and not the area models. So we all automatically see that we're dealing with 18 wholes. Well, that doesn't help us there because 18 and this 18, they're both equal. So we know that we're dealing with the whole number of 18, so that's not going to help us. We need to jump right into the fractional part, the decimal, the 1900ths and the 3/10ths. So we need to find the 1900ths on here and then the 3/10ths on here. But if you look over here, it already split it up. Here's 18 and 1/10. Here's 18 and 2/10, 18 and 3/10, and 18 and 4/10. So let's do our number bond for 1900ths because we already know that we're dealing with the 18 wholes. So we don't have to take that one apart. So 1900ths, we get 1/10 and we get 900ths. Okay, well we see right here, 1/10 is right there. That's 18 and 1/10. That's that part. But we now got to focus on where does 900ths go? Well, guys, remember, just like we did in the area models, remember that within these little sections right here, this is all broken up into tenths, right? This whole thing is tenths in between. All of these little things between each of the regular tenths inside becomes another tenths, which is equal to 100ths. So where would 900ths go? Well, we know we have 1 here, 2, 3, 4, 5, 6, 7, 8, 9. So we know that 900ths is going to go right about, let's change that, right about right there. So there is 18 and 1900ths. That's where that one would go. And we see on the other side 18 and 3/10. Well, guys, that is right here. So we automatically can see that 18 and 3/10 is bigger than 18 and 1900ths. So let's put our sign. 18 and 1900ths is less than 18 and 3/10. All right, now we're just comparing them. We're not using a number line. We're not using area models. We're just going to look and study at each place value. So if we notice, look, there's 2. There's 2 wholes right here. So that doesn't really help us. Right now, just by looking at the 2 wholes, they would be considered equal. So now we got to go to the tenths. And right here is the major deciding factor. If you compare these two, we can see that 6/10 is bigger than 5/10. Okay, and if we go even further down here, this 800ths and 400ths. Well, guys, the deciding factor is what number is in the tenths place. And just by looking at that, we know that 6 is larger than 5. So 2 and 68 hundredths is larger than 2 and 54 hundredths, because the tenths place is telling us that the 6 is larger than the 5. Our next one is 9 and 28 hundredths is greater than, less than, or equal to 7 and 28 hundredths. Well, guys, this one is a dead giveaway, because if you notice, there is a 9. They have 9 holes. Here's 7 holes. We don't even need to look at the 28 hundredths, because 9 is larger than 7. So our big 9 and 28 hundredths is greater than 7 and 28 hundredths, just by looking at the holes, the ones place. Okay, our next one is 13.1 is greater than, less than, or equal to 13.10. So we've clearly looking at both of these decimals, we can see that they have a 1 in the tens. They have 3 ones. So right now it's a tie. They're both equal. But now let's look into the decimals. And in the decimal, I see a 1/10, but I also see a 1/10 on that side. Then over here we have a 0. There's no hundredths. Well, if we go to this side, there's no hundredths on this side either. So you would think that just by looking at this one would have been greater, but there's no hundredths and there's no hundredths. So obviously these guys are equal. Now another way to kind of to look at this and understand really what's going on, we could just say that 13.1 is equal to 13 and 1/10, and 13 and 10 hundredths looks like this as a fraction, right? And how they're equal, because look, if I divide the top and the bottom by 10, I'm going to get 13 and 1/10. They're equivalent, see? It's the same. Just by dividing by 10 can show you that. All right, our next one is 8 and 39 hundredths is greater than, less than, or equal to 8 and 39 tenths. Notice that this is the tenths, it's not hundredths, or they would have been equal if that was 100. But this is tenths. So we got to remember, just like when we did the fraction unit, we got to pull those holes out. Got to pull those holes out. So keep the 8, and we're going to add on. So how many holes are there in 39 tenths? Well, there are 3 holes, because 10 tenths plus, remember we did this, 10 tenths plus 10 tenths plus 10 tenths gives us 30. And how much is left over? 9 tenths. So we've got 3 holes, 1, 2, 3, and 9 tenths left over. So if we add this up, this becomes 11 and 9 tenths. So this 8 and 39 tenths is really equal to 11 and 9 tenths. So 8 and 39 hundredths, well, this one, let's convert this into a mixed number. Can we see which one is greater? Well, just by looking at the whole, we know that 8 and 39 tenths, or 11 and 9 tenths, we can put this back into a fraction. Just by looking at that, the whole is bigger. So 8 and 39 hundredths is less than 8 and 39 tenths, which really is 11 and 9 tenths. Okay, our next one, 3 tenths is greater than, less than, or equal to 22 hundredths. Well, 3 tenths looks like that as a fraction, 22 hundredths. What does it look like as a decimal? 0.3, because 3 tenths, and 0.22 hundredths. So just by studying those decimals, we can see that they have no holes. So there's a match. no holes. So far, it's a tie. If we go to the next one, into the tenths, we see there's a 3 and there's a 2. So automatically, we see that 3/10 is larger than 2/10. And so we would make 3/10 is greater than 22/100 because the 3/10 is larger than 2/10. We don't even need to go into the hundredths because the tenths tells us who's the winner. And the winner is 3. 3/10. You got this, you guys. Okay, problem number 1. Compare the two decimals. 0.4 is greater than or less than or equal to 0.32. 4/10 is greater than or less than or equal to 32/100. Okay, second one. Compare the decimal and the mixed number. Okay, so we got 1 and 2/10, and then we have 1 and 42/10. Okay, so be very careful. Got to pull out those holes like we did in the fraction unit. Pull out those holes, and don't forget that it's attached to a 1 hole. Okay, and then see who's bigger. Compare 5/10 to 33/100. Who is larger? To be continued. More math fun tomorrow. Have a great day, guys.